So welcome to the second lesson in this OpenGL programming series, in which we're using C# as our programming language. And so in the previous part, the part 1, we got this output. This is just a single OpenGL window, which we OpenGL window. So the window is currently empty. We use the game window class of the OpenTK library to create the window. In this tutorial, we are going to do a couple of things before we start drawing stuff onto the screen. So first we need to initialize the viewport, and then we'll set up the projection to the projections. And by projection I mean the coordinate system on the screen, which specifies how the images are mapped onto the screen. And then we'll draw a simple triangle, and I'll also talk about a bit of other drawing primitives, although I'll make a separate video on the drawing primitives, and also separate video on the projections, because projection is quite a vast topic. So first we need to initialize a viewport, what is known as a viewport. So what is a viewport? Actually, a viewport is the box on your screen in which the scene is rendered. Like viewport, like if the whole of your screen is the viewport, your scene will cover all of your screen. But if you want to render other GUIs on the screen, let's say on top of your screen, so you will specify a viewport which does not cover the whole of the screen. It covers the lower part, and upper part you can use to create other GUI. So the viewport is actually the rectangular box in which all of your scene is rendered, in which the image is rendered by OpenGL. So before we start creating a viewport, we need to know from which function we need to call the viewport creating routine. Before that, I'll tell you about another event handler, which is resize. And this event handler is a part of the game window class of the OpenTK library. This is quite a useful one. So this function assigned to this event handler is called whenever the window is first created. Always when the window is created, this function is called. And after that, whenever you resize your window or minimize or maximize your window, this function will be called. So if you specify a viewport in this and create the viewport according to the width and height of the window, so the viewport will be resized automatically whenever you resize your window. So let's say if you're going to create the viewport equal to the size of the window, so so the size of the viewport will change with the size of your window. But if you specify that your viewport in any other function, it might happen that you are resizing your window but your viewport size is the same, and the image is being rendered only on the small part of the screen when you maximize your window. So to avoid that, we'll use this function to call our viewport setting routine. So I'll assign a function to it. Oops. Okay, now we'll define this function down here. Holy crap. Okay, so we're done, and now we can call here the routine to set the viewport, which is actually gl.viewport, and you can see it actually takes 4 arguments, which are the points which specify the rectangle. So if you have worked with any of the rendering APIs before, you might know how to specify a rectangle, but let's just say this is our window. So we need a viewport equal to the size of the window. So if you've worked with coordinate systems before, you'll know that the coordinates of the window are in this way. The top left corner of the window is 0, 0, and the bottom right corner is always equal to the width, height. The width of the window this much, and the height of the window this much. So this is the both x and y values are positive here inside the window. So if you want to specify a viewport which is equal to the size of the window, which means this much size, you will need to pass the arguments to create a rectangle of this size. So this will be very simple to create. You just pass these 0 comma 0 as the first two arguments and w comma h as the second arguments, which will specify these two vertices, one this and two this, and a rectangle will be created out of it, which will cover whole of your window. So the viewport size will be equal to your window, and whenever you resize your window, it will also be resized according to it, because you're calling it from the resize function, which is assigned to the resize event handler. So pass the arguments accordingly. These do not need to be in the floating. Yeah, these are integers actually. So the width and height of the window, we specify them here, 500 comma 500. So you can actually, these are actually public members probably. Yes, public members, so you can access these both from here, and you can set your windows width and height accordingly. So pretty cool. Then after setting up the viewport, the next thing you'll do is set up the projection. So what the projection does, the projection concept of the projection is very vast. There are two types of projections, orthographic and perspective, in which the perspective is usually used for 3D games and other 3D scenes, but the orthographic is usually used for 2D or your other engineering designs. But we'll talk about that in any other video, and I'll just give you a little bit of glimpse that what a projection matrix is, so that you can just work with this function, which I'm going to call here, although I'm not going to tell you much of it. So the projection specifies how the vertices you specify are mapped onto your screen. So basically you just specify a coordinate system. So what we need to do here is we create, suppose this is our viewport, and we'll need a coordinate system like this. So this is the point 0 comma 0, and you can actually specify what values does this point hold. So you can actually assign 10 comma 10 to it. So this will, your coordinate system, the x 10 comma 10 point will be the topmost point of your viewport, in our case the topmost point of the window, or you can instead specify this point as 100 comma 100. So this is what the projection does. You can actually set up your coordinate system onto the screen, or in the perspective projection in 3D you can actually decide from which point you are looking and looking at which point. So that is quite complicated, but we are just working on the 2D projection here. So in the projection that we'll create, we'll keep this equal to 50 comma 50. So this point will be 0 comma 50. We want because we want this as the first quadrant of the Cartesian plane, so we'll keep both values positive here. So we need a coordinate system like this, and this point will be 50 comma 0. So this will be positive x-axis, and this will be positive y-axis, and this will be our origin right here. So we want a coordinate system like this, and if you would draw in any negative value of x-axis, the point will lie here, or negative value of y-axis, or both negative in this quadrant. This will not be visible actually. So to specify a 2D projection, before we specify the projection, we need to go to the projection matrix. So OpenGL usually has a state variable, which is a matrix mode, which specifies that the target for the matrix operations, like you call any operations you apply to the matrix, which matrix is the target for that. There are matrices like the projection matrix and the model view matrix. In the model view matrix you usually draw stuff, and in the projection matrix you set up the projection, the camera, the look direction, etc. So we need to set up the projection. So for that we need to be in the projection matrix, gl.matrix mode, and the matrix mode dot projection. So we have now switched to the projection matrix, and now I'll tell you another function which is called load identity. So what this function does is that it resets the state of the current matrix, which is projection matrix. Here we are inside the projection matrix. It resets its state. So the state of the projection matrix is reset, because when we specify a projection, it is not entirely created. The projection matrix is not entirely created, but what it does is that when we specify a projection, it multiplies the current projection matrix with the matrix that we specify. So after every time we specify the matrix, we should reset it to avoid any unexpected results. So now we can specify our projection. So we need an orthographic projection. We'll talk about the perspective in any of the part, and I'll also explain the orthographic projection, how it looks, how it works in any other part. But just showed you the coordinate system we want, and we want to create it like this. So the first argument is the leftmost point of our projection that is visible to us, which will be 0. You can have a look at it. And the rightmost point we need 0.0, and the rightmost point, the second argument, we need 50, and the bottommost point we need 0, and the topmost point we'll keep 50.0. You can also make your projection to hold all the 4 quadrants of the Cartesian plane if you specify this as -50 leftmost, and the bottommost as also as -50, but we'll just need the first quadrant on the screen to keep stuff simple, and only positive values will exist on the screen this way. And the next 4 arguments are the z near and z far values. You do not need to worry about them, but I'll just let you know that these specify the range in which the objects drawn by us are visible. So we'll draw in the 2D plane on the x and y axis. We'll not go on to the other values of z axis. We'll stay on 0. So we just need a range in between which only 0.0 should be we need the point 0.0 on z axis. That plane we need to be visible. So we'll specify this range accordingly. And so we now have our orthographic projection, and so we'll draw stuff after that. So always when the resize function is called at last, because by default we are in the model view matrix, and when we change the matrix mode to projection and specify the projection, we need to switch back to the model view matrix so that we do not we do not get any unexpected results. Model view matrix, we need to go to the default matrix, because this is used to draw stuff, and we will not change the matrix mode when drawing our stuff before that, because we are by default in the model view matrix. So we'll always try to stay in the model view matrix except when we are setting up the projection or any other stuff, so that we do not get any unexpected results. So simple tip, always stay inside the model view matrix. So now we can start drawing. So how currently we do not know anything about drawing. So in OpenGL, when you need to draw stuff, you need to specify them as separate vertices. So we specify a set of vertices which and OpenGL figures out how to draw the primitive according to the vertices we have specified. So before we start specifying the vertices, we need to call a function named glBegin. It tells the OpenGL that we are starting to describe our vertices, because if we specify any of the vertex before this, it will not take effect, and it takes some arguments. I'll just explain this in a while. And the other function gl end, and we need to specify. So this simply means that we need to specify our vertices between the calls to glBegin and glEnd. Only then the vertices will take effect. So start here and end here, and between this we specify our vertices. So the arguments that glBegin takes is the begin mode. So this begin mode actually specifies what type of the primitive we need to draw. So like you specify vertices. All the points are not to be shown as vertices on your screen, but you actually need, like when you need to draw triangles, you need to draw quads. So I'll just explain the primitives so to you just a bit, although this is also a fairly vast topic. So on majorly we'll talk about primitives in any other video, but here I'll explain some stuff to you. So basically one of the primitive is points. So the first primitive which we're going to talk about is point, the simplest one. So when you are currently drawing using this as a primitive, all the vertices you specify, like this is your screen, and according to your coordinate system, this 50,50. Okay, I'll not write it here, just time consuming. And this is your origin actually. So you specify vertex which is 25,25, which lies here. I'll just keep it a comma b. This vertex lies here, let's suppose. So on your screen a point will be displayed on your screen which is whose size is exactly 1 pixel. If you want it bigger, you can change it using a call to the function gl dot point size, but by default the size is 1 pixel. So when using this primitive, all the points you specify will be showed up on your screen like this. But what if you want a solid primitive, like you want a triangle to be drawn on the screen, a solid triangle? So in this case you cannot actually describe a lot of vertices to make a filled triangle like this, but what you need to do in this case, you need to change your primitive that you're using to draw. So if we use triangles as a primitive, what will happen, that a set of 3 vertices will be joined into a solid triangle. So like this is the first vertex you specify, let's number them, vertex number 1, vertex number 2, and let's say you specify these vertices in the same order, 3, then you specify this vertex, and then this vertex number 5 and 7. So you have currently 7 vertices, but triangle has 3 vertices, so only the multiples of only 6 vertices will take effect here. So the first set of 3 vertices will be joined into a triangle, and then the next corresponding set of the 3 will be joined into a triangle, and this will be left alone, so nothing will be rendered onto the screen, not even this point. So only 2 triangles will be seen on the screen. If you want another triangle, you can specify 2 more vertices and another triangle will be made. Similarly, there are a lot of primitives. We'll talk about one more quickly here, which is quads. So you can probably make it out by the name that a set of 4 vertices will be joined into a quadrilateral, although this quadrilateral should always be a convex one. If it is concave, I don't know what happens. It is probably not rendered onto the screen, so it only renders convex quadrilaterals. You use some different techniques to render concave quadrilaterals if you want. So begin mode, now we are familiar with this. So begin mode, we'll try drawing triangles, and now we can specify a set of 3 vertices to tell OpenGL that what kind of triangle we want. So we are familiar with the coordinate system that we had on the screen. The top right corner is 50,50 and the origin is the bottom left corner. So we have the coordinate system. Now we can specify some vertices. So I'll just so now to specify the vertex, you call the function gl.vertex. okay, there are actually 3 functions: vertex 2, vertex 3 and vertex 4. So the vertex 2 specifies only x and y values, vertex 3 has x, y and z, and this vertex 4 has x, y, z and w values. We'll not talk about this w, but if you use the vertex 2 to specify x and y values only, the z value is by default always 0, because OpenGL always takes the point input as 3 values, x, y and z. If you're using vertex 2, the z value is always 0. Or you can alternatively do that this way, that you specify the x and y values in the vertex 3 function and keep the z value 0 in this function. This will be same as the vertex 2 function. So for the sake of simplicity, we'll just use the vertex 2 function and specify x and y values, because we're working with 2D and the z value will always be kept to 0. You can read this description here. So we'll specify 3 points now. So let's keep the first point 1.0, 1.0, and the second point I'll keep 49.0, 1.0, vertex 2, and this will keep 25.0, 49.0. and now we can build and run our program to see what's the output, and there is our triangle. You can compare this with the vertices you specified. You can take a graph paper and check if the vertices of this triangle are in position. Although you can try changing these vertices. You change it to 19, I'll change it to 5, and the triangle will be drawn accordingly. Always, you can see there. You can see that the default color of the triangle was white. So this tells us that the default I'm sorry, the default drawing color of the primitives in OpenGL is always white, although you can change it, and we'll talk about more about that in the next part. And in the next part we'll also do a basic animation. So just a basic rotation animation. We'll just first color this triangle in the next part, and then we'll rotate it. The rotation will be rotation animation that'll be very simple to do, and the part after that I will probably talk about the projections and maybe something else, but I'm not sure about that. So this is all for this video, and check out other videos on my channel if you've not done yet, I have also included the link for my Facebook page down in the description. You can like that page to get updates, and you can connect with me using the page. You can send messages and have feedback. So this is all for this video, and I'll see you next time.